This video is all about the first sample problem for vectors. Now let's read the problem. A load of W is equal to 4,000 newtons is supported by two ropes, one of which makes an angle of 30 degrees with the horizontal, while the other rope makes an angle of 70 degrees with the horizontal. Now we're going to calculate the force exerted by each rope so as to provide equilibrium. Now, let's proceed with our solution. The first thing you're going to do is to provide a force body diagram or a free body diagram for this problem. I repeat, the first part of this solution is to provide a clear diagram for this problem. Now, if we're going to represent this problem, there is a weight of 4,000 newtons, which is supported by two ropes, A and B. Let A be the force with angle 70 degrees. Okay. Now, the variable A represents the rope which holds the angle of 70 degrees with respect to the horizontal, whereas the latter B be the force with the angle 30 degrees. As you can see here. The next thing with our solution or the next step is to elaborate further the diagram. And we have to bisect each forces or components of each forces so as to solve the problem. Now for rope A, since it makes an angle of 70 degrees with respect to the horizontal, as you can see here, A and then 70 degrees with respect to the horizontal. Now, we're going to represent the horizontal force for A as AX and for vertical force of A as AY. Okay? So, the horizontal force AX points towards the left and AY points towards upward. Okay? So if we're going to determine now the vertical component of force A, so since AX is adjacent of the angle 70 degrees and hypotenuse, so we are given with adjacent side and hypotenuse. So we're going to use the trigonometric function as cosine. So cosine of 70 degrees is equal to adjacent AX all over hypotenuse A. To bring out AX, we have to cross multiply A to the other side of the equation. So AX becomes A multiplied with cosine 70 degrees. Now let's proceed with force AY. AY is opposite of the angle 70 degrees and it's near to the hypotenuse A. So we are given with opposite side and hypotenuse. So sine 70 degrees is equal to AY, which is the opposite side all over our hypotenuse A. To bring out AY as unknown, AY now is equal to cross multiply A times sine 70 degrees. Now let's proceed with force B. Force B is represented as the rope withheld at 30 degrees angle. If we're going to bisect force B or rope B with force B, we are given with a horizontal component pointing towards the right and a vertical component pointing upwards. Okay. Since BX is an adjacent side and we are given with the hypotenuse, so cosine of 30 degrees is equal to BX all over B. Bringing out BX, this becomes BX is equal to B multiplied with cosine 30 degrees. And for vertical force By, since this is an opposite side and we are given with a hypotenuse B, so sine 30 degrees is equal to By all over B, bringing out By, this becomes By is equal to B sine 30 degrees. Now the next step of the solution is to summate forces or determine the summation of the forces. The first thing is to determine the summation of forces with respect to the horizontal or Fx. So summation of Fx is equal to 0. Okay. Now let's use our signage for forces that points towards the right, that is positive. For forces pointing towards the left, those forces are negative. Okay. So these diagrams, okay, we're going to use, we're going to determine the forces horizontal. Okay. Our force AX, since it points towards the left, it is negative. Our force BX points towards the right, it is positive. So if we're going to represent it as an equation, BX minus AX is equal to 0, or positive BX minus AX is equal to 0. To further expound the equation, our BX is equal to B cosine of 30 degrees minus the expanded form of AX here, A cosine 70 degrees is equal to 0. Now, the next thing to determine is our forces vertical, Fy, or summation of Fy forces vertical is equal to 0. For forces pointing up, we're going to use positive. And for forces pointing downwards, we're going to use negative. Okay? So with the following diagram here, where my cursor of my mouse points at, AY and BY points upwards, whereas the weight 4,000 newtons points downwards. So AY plus BY minus 4,000 is equal to 0. BY plus AY minus 4,000 is equal to 0. Or if we're going to further expand or expound the following terms, BY, since BY is equal to B sine of 30 degrees, we're going to use this as B sine 30 degrees plus the expanded form of AY, A sine 70 degrees, okay, plus A sine 70 degrees minus 4,000. Now, this is our second unknown equation. And the first one, B cosine 30 degrees minus A cosine 70 degrees, is our first unknown equation. Now, how are we going to further simplify this, since we got two variables and two equations, two unknowns, or two unknown variables, two equations. Now, since this problem is linear, so we're going to use solving two unknown linear equations with two unknown variables. So since our first equation is B cosine 30 degrees minus A cosine 70 degrees is equal to 0, we're going to transpose A cosine 70 degrees to the other side of equation. So this becomes B cosine of 30 degrees is equal to A cosine 70 degrees, or bringing out B as a single variable to the left side of equation, dividing both sides of equation with cosine 30 degrees, this becomes B is equal to A multiplied with cosine 70 degrees all over cosine 30 degrees. Okay, so this is the simplified equation for the first unknown. Now, let's substitute this first unknown equation to the second unknown equation. So this becomes our second unknown equation is b sine 30 degrees plus a sine 70 degrees minus 4,000. If we're going to substitute this one into this or the first simplified equation to the second equation, okay, the form becomes a cosine 70 degrees all over cosine 30 degrees multiplied with sine 30 degrees plus a sine 70 degrees is equal to 4,000. Why is this positive? Because transposing negative 4,000 to the other side of equation becomes positive. Now, further simplifying the whole term to solve a, we need to factor out a. So this becomes a cosine 70 degrees multiplied with sine 30 degrees all over cosine 30 degrees. This is tangent plus sine 70 degrees. And then dividing both sides with both sides of the equation with the following constants, this becomes in this form. A is equal to 4,000 newtons all over cosine 70 degrees multiplied with tangent 30 degrees plus sine 70 degrees. Now, further simplifying the following terms gives us an answer of, for cable A, it has a force of 3,517.54 newtons. Now, if we're going to solve now for B, we need to substitute this value to our simplified first equation. So this becomes B is equal to 3,517.5410 newtons times cosine 70 degrees all over cosine 30 degrees. And this brings up to our final answer for rope B with a force of 1,389.1854 newtons. Our next video will tackle about the second type of problem for vectors.